Hello everyone, in this video we'll see how the conversion of multi-springs, multi-masses and multi-dampers can be done into single spring, single mass and single damper system with the linear coordinate system. Now, what exactly is the dynamically equivalent system? If let's assume there is an actual system and we want to create a dynamically equivalent system, that means that whatever is the are the forces acting on the actual system and whatever is the effect because of these forces on the actual system, it should be same as that on the equivalent system. The forces and their effects on actual system should produce the same effects on the equivalent system. So we already know that these masses are also called as the inertial masses or the inertial bodies, and their function is to absorb or give out the kinetic energy whenever there is change in velocity of the system. So what we have to do to find the dynamically equivalent system, we have to replace multi-masses with single mass. So for that we have taken a case, there is a rigid bar with pivoted at some point O, and it has got three masses M1, M2 and M3 at three different points A, B and C. And the distance of these masses from the pivoted point are given by L1, L2 and L3, and their velocities are given by x1 dot, x2 dot and x3 dot respectively. The idea is to replace these masses M1, M2 and M3 with an equivalent mass such that its velocity is also equivalent to that of these three masses, right? So if I say that, that means the kinetic energy of all the three masses, which is half mv square. So it becomes half m1 v x1 dot square plus half m2 x2 dot square plus half m3 x3 dot square. It should be equal to half equivalent mass and the equivalent velocity square of the system. So I want to find the velocity of the equivalent mass in terms of these three values. So what I have to find? I have to find the equivalent velocity of the system. So if we assume for small displacements of the body, x2, we are finding it in terms of L1, right? Because we are assuming that when we are replacing the system with equivalent mass, we are placing it at the position same as that of the mass 1. That means at point A. So the position of M equivalent will be at distance of L1 from the pivoted point. Therefore, to find the velocity x2 in terms of this L1, so x2 dot becomes L2 upon L1 into x1 dot, right? X3 dot becomes L3 upon L1 x1 dot, because we are placing the mass at this place, right? So what exactly happens, that the velocity of the equivalent mass becomes equal to the velocity of x1 dot, right? Or the first mass, the velocity remains same because we are focused on replacing the system with equivalent mass. So we are assuming that whatever mass we are keeping at this point, its velocity is same as that of the velocity of mass 1. So if we place x equivalent, x dot equivalent as x1 dot, so the equivalent mass equation that we get is this. Now springs, which are the restoring components. So how we can replace the multi springs when these springs are in series? So there can be different combinations. Let's assume that the springs are in series. So let's say there are two springs with spring constant S1 and S2 when there is no mass attached to it. Now if we attach some mass to it, what exactly happens? Some displacement takes place, which we are saying that some displacement delta ST takes place. Now whatever is the displacement is the sum of the displacements of spring 1 and spring 2. So let's say the displacement produced because of spring 1 is delta 1 and displacement because of spring 2 is delta 2. So we draw the free body diagram of both these springs, what it is. So spring 1, some force because of this, the weight because of the mass applied is same on both these springs, right? So the weight is applied on this spring and it is equal to S1 delta 1, and for body 2 it is S2 delta 2, right? And what we have to do, we have to replace both these springs with a spring which is producing the effect equivalent to that of both the springs. So we know that S1 delta 1 is equal to S2 delta 2, because whatever is the weight that is being applied. Now weight is being applied in the downward direction and this is the reaction. So whatever is the weight is same for both the bodies. So S1 delta 1 will be equal to S2 delta 2, which is equal to S equivalent delta ST. So what is delta 1? It is in terms of, it will be this if we take these two equations, S equivalent delta ST upon S1, and delta 2 if we take these two equations becomes S equivalent delta ST upon S2. And we also know that the total displacement is the sum of displacement produced by spring 1 and displacement produced by spring 2. So if we place this delta 1 and delta 2, so this equation plus this value, it gives delta ST. So what we get, that the equivalent spring stiffness is equal to 1 upon S1 plus 1 upon S2. So whatever may be the n number of springs are attached in series, so the equivalent spring stiffness will be given in this way. Now if the springs are attached in parallel and we want to replace that system with a single spring, so let's say two springs are attached with spring stiffness S1 and S2. So if we apply some weight, what will happen? The displacement is produced, which is delta S2. But in this case, what happens? The displacement is, so the weight of this spring is actually balanced by the spring force, that is S1 delta 1 and S2 delta 2. So equation becomes W is equal to S1 delta 1 plus S2 delta 2. So for equivalent system, W is equal to what? S equivalent delta ST, right? So this is what the equation that we get. But we also know that the displacement produced in the system is same, right? So delta 1 is actually equal to delta 2 and which will be equal to delta ST, right? For whole of the system, the displacement will be same. So what will be the equation of S equivalent? It will be S1 plus S2. So whatever is the number of springs that we attach in parallel, we'll always get S equivalent, which is the sum of the S1 plus S2 plus S3 up to Sn. Now to replace the multi-dampers, now we know what is the purpose of multi-dampers. They are used for the energy dissipation. So if we are using the dampers in parallel, right? So what exactly is happening? The force. Now we also know that the damping force is proportional to the velocity of the system. So this is the damping coefficient C into velocity, that is Cx dot, right? So what we have to do if in case there are parallel dampers, so what exactly happens? The force is same for both the bodies like we did for the springs, and if the displacement is same, the velocity is also in this direction. So Fd will be what? C2 x dot, because the velocity will be same for whole system and it will be C1 x dot. So C2 x dot plus C1 x dot will be equal to what? The force into its velocity. So therefore, if we want to replace the dampers in parallel with the equivalent damper system, we have to satisfy this condition that the C equivalent is equal to C1 plus C2. And if the dampers are connected in series, so if the displacement, right, so for both the springs the displacement was different, so for both the dampers displacement is different, so the velocity will also be different, right? So x2 dot, so for the equivalent system it will be x dot will be x equivalent, or x dot equivalent will be equal to x1 dot plus x2 dot. Therefore, the damping coefficient or the equivalent damping factor, it is similar to the case of the springs. So it will be 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. Or there may be n number of like dampers, so it will be plus 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 up to Cn, and this will be plus plus up to 1 upon Cn.